Hi, it's Paul Browning from howtonetwork.net. So welcome to the lecture on VLANs, or virtual local area networks if you want to use the full terminology. So in this lecture I'm going to cover a few different things. We've got a rough outline here on the whiteboard. VLANs overview. We'll start off with some VLAN basics. Like everything, every technology, there's rules that we should follow. Some of them you have to follow and some are just recommended, but we'll be looking at some of those. We'll also be looking at the difference between access and trunk links. You're going to be expected to know the difference for the Cisco CCNA exam, and we're also going to look at configuring access and trunk links, and it's important you can do both. We're going to look also at broadcasts on a VLAN, why it's important we know about broadcasts and how they work and affect your VLAN. And also we'll be looking at some configuration. So I'd like us to do a simple VLAN configuration on one switch, where maybe we have two VLANs working on the same switch. And then what I'd like to look at also is how we can have VLANs spanning multiple switches, because this really is the whole point, and this is what we'll be doing on a live network. And also obviously be expected to know how to do this on the Cisco CCNA exam. You'll be tested theory on the theory part quite heavily, and you'll also be tested on the configuration. Now VLANs and switching is an area that a lot of people seem to avoid for some reason. I think they do find it hard, and there's a lot of different rules involved and improvements over the year. For example, the 802 standards, and now we've got rapid spanning tree, which we'll cover in a different lecture. But we'll come back to this whiteboard shortly. I would like to draw your attention to Cisco's definition of what a VLAN is. I'll read it out as well. Virtual Local Area Network, VLAN. It's a group of devices on one or more LANs that are configured using management software so that they can communicate as if they were attached to the same wire, when in fact they're located on a number of different LAN segments. Because VLANs are based on logical instead of physical connections, they're extremely flexible, and that's copyright Cisco Systems. So there's just one part of the definition I particularly wanted to draw your attention to. I'll just underline it here with my fancy pen, and this is the part here. So basically they can communicate as if they're attached to the same wire. I'm going to be explaining this in more detail later, but if you can grasp this fundamental concept, all devices on the VLAN think they're basically attached to the same wire. They've got no knowledge that they are part of a VLAN, and that's a good thing really. We don't want any more complexity than we need when we're configuring our local area networks, and obviously the same principle to our wide area networks. So why would our end devices need to know? So we'll be looking at this, but really you can have a number of different devices on the same VLAN, and they could be spanning multiple switches and even multiple buildings, depending on how you've got your network set up. Alright, so without further ado, we're going to look at a simple network topology. What we have here is we'll say this is a hub to start with. And if you've been in IT long enough, or even if you've actually bought one from a local computer store for a home network, you'll realise that a hub is a very basic device. I'll put it down here. So I'll call this a hub, and excuse my writing, I'm using a tablet PC here. Alright, so we've got all our different devices. For the sake of simplicity, I've put them down as PCs, and I'll give them a very cunning identification system. A, B, C, D, E, are you following this? F, G, and H. Alright, so as devices on a local area network do, they send information, and let's say for example PCA wanted to send information over to PCB. Well, that's the beauty of having a hub, that's quite easily done. Say for example it's an email, it gets sent from PCA across the wire. So this is your Ethernet cable going into your hub. The thing about a hub is it's not an intelligent device. It has got no way of storing a directory of addresses like a switch does. So a frame that goes into a hub gets sent out. No, it does go to PCB, so that's good news. But unfortunately, because the hub has no intelligence, the frame also gets sent out to every device on the wire. So it's like going outside your house and you want to speak to a neighbour. I love metaphors. You want to speak to your neighbour, but you shout out the top of your voice and everyone in the street hears what you've got to say. So that's how the hub works. Now the message is received. We haven't finished this story yet. The message is received by PCB and it sends a reply to PCA, and you know what's coming next, don't you? It goes out to every single device on the wire again. Do I need to draw every arrow? No, you're probably bored watching by now, so you get the picture. The other problem we have when we use the hubs, and they are still used obviously on home networks, and even some companies, small businesses are too cheap to go out and buy a switch. I don't think they quite realise what the repercussions are. So let's look at another colour. I've got so many to choose from here. Let's choose this colour. Say for example PCB sent out this message onto the wire, but as a frame was coming in, say it collides on the wire. So what we've got here is a collision, and it's where two frames on the wire hit each other. Now if you've read about collision access detection, you know this doesn't happen with Ethernet. But for the purposes of this demonstration, we'll say there's a collision on the wire here. Now unfortunately that bad frame also affects all of the devices. So I'll just quickly put some arrows here. But what we have is a huge amount of unnecessary traffic flying across our network. So basically these are the foundations of packets or frames, traversing on the wire, and the reasons why we needed a switch in the first place. Alright, so now we've got rid of all of that. What we'll say now is, instead of using a hub, now we've got a switch. So basically what a switch is a directory of networks. You can consider it like a phone book or some sort of other directory where it can store a table. You have in the United States, you've got zip codes, and as you drill down to different parts of the zip code, going further along from left to right, it will drill further down from a state into a city, and then a district within the city, then a street, and eventually you'll get to one side of the street. So in the UK we have postcodes, and a postcode will get you all the way to the left hand side of the street, for example. If you went to the right hand side it would be a different postcode, and then all you need is the door number, and then you've got the correct address. So let's give our devices names again. A, B, C. I wasn't the world's neatest writer at school, as you can see. So we've given all our devices names now, and let's say that PCA wants to send a message to PCB. Now if you've just booted this switch up, it will have 0 addresses in its directory stored on a CAN table. So what will happen is the frame will come in